Welcome to qnawire.
So the question asks us, by how much will the water level rise given that we have placed this weight of metal on top of this barge? So we can find an associated uh, height change of the water as delta y, and this can be related as the change in volume divided by the surface area of the water. Dimensionally, this makes sense. If volume is meters cubed and area is meters squared, this will of course give us a meter, give us a unit of meters, and meters is of course the unit of this y value here. We can define a weight to be mg, and then we can also define a mass to be the change in volume times a density. And not P, but rho. So if we find this, we can say that the weight can be equal to the change in volume times the density times the gravity. And we're trying to find delta V. So delta V could be equal to the weight divided by the density times the gravity. And here, the density that we're going to be using is, of course, water. So we can say that the associated height change is going to be delta V, which we're going to substitute this in for. And we have the weight divided by the density of water times the acceleration due to gravity times the surface area of that water. Simply need to plug in. So we have 2.5 times 10 to the 6th newtons divided by the density of water of 1,000 kilograms per cubic meter, rather. And then the acceleration due to gravity is, of course, 9.8. And then the surface area of the water, we have a length of 60 meters and a width of, we'll say WI, of 20 meters, so that we don't get confused with weight. So we can just say 60 here times 20, where the surface area is simply going to be the length times the width. And solving for this, we have a 0.213 meter difference. So this is going to be by how much the water level increases, given that we have put 2.5 times 10 to the 6 newtons of metal on top of this barge. Now, the second part of the problem asks us to find the associated change if we were to throw this metal off the barge. And if we were to throw the metal right off the barge, we'll be using the exact same formula. However, we can say that this is going to be the density of the metal times the gravity times the surface area of the water. So again, we're simply going to plug in 2.5 times 10 to the 6 newtons. And then we have the density of the metal. Here, the density of the metal is going to be 7,200 times 9.8, and again times 60 times 20. This is going to be equal to 0.0295. And this, we can annotate this as delta y prime, and this is for part A. For part B, we simply need to do delta y minus delta y prime, and this is going to be, of course, 0.213 minus 0.0295, and this is going to give us a 0.183 meter difference. So this is going to be part B, and this is going to be by how much the water level sinks after throwing the metal off the barge. And that's the end of the solution. Thank you for watching.